Okay guys, welcome to week 7, and we're still talking limits today. Like I said before, it's a huge deal in calculus what a limit is. It never goes away throughout the whole year, and sometimes you don't have a graph to look at. And so whenever you don't have a graph to rely on or to look at, you've got to know what's happening as the limit is approaching a specific x. Now, the first kind we're going to do is the easiest. It's plug it in is what I wrote. But in the books or elsewhere, your teachers will tell you to use direct substitution, is what it's called. Meaning that, remember, a limit is what y value are you approaching. And in a lot of cases, the y value you're approaching is the y value where you exist. And so because of that, there are several functions that, you might see, like x is approaching 2 over x minus 3. Okay, so let's say that you see something like this. And, yes, it's a rational function, and you might start looking at this thinking, okay, so there's going to be asymptotes, there may be a hole, and you may try to figure all that out. Well, that's all good and fine. However, you need to look here first, because sometimes the number that's here has nothing to do with any of the asymptotes. And the way that you're going to know that is by trying to substitute it in. So if you just plug in this number and math it out, 4, 12, 11 over -1, okay, if you can plug it in and you get a real number answer, that is your limit, okay? That is your limit, because what it means is that on this graph, the point 2, -11 exists. And in this case, the limit is where the function actually exists. If that had been a 3, then yes, we have a problem. But we didn't on this one because it actually was able to plug in. Same thing with something involving trig. Just because you see a 0 doesn't necessarily mean that everything's going to be bad, like 3x plus 1 over, let's say, the cosine of x. Okay, so if you see trig and you freak out a little bit, you really shouldn't, because you first need to try what I just said. Take the 0, plug it in everywhere. And on this one, if we plug in a 0 on the top, we're going to get a 1. And if we plug in the bottom, you're doing the cosine at 0 degrees. Well, the cosine at 0 degrees is actually 1, right? Because that's the x value at 0. And so there is, once again, there is a real number. So just because you see 0, or just because you think the bottom's going to be 0, don't freak out. Really plug it in first and see what happens. So now the question becomes, what if you try to plug it in and you don't get a nice, pretty answer, like we did on one of those two? Well, when that happens, and the answer is undefined, then we have to really think about this problem graphically. So let me go back to the one that was up here, and I'm going to change that to a 3 now. Okay, so if this right here had been the problem, and I tried to plug it in, then what's going to happen is you're going to get something like 26 over 0. Okay, and whenever you plug in and you get 26 over 0, that is a problem. That means that on the graph, it's either going to be a hole or a vertical asymptote a lot of times. And I'm not going to say every time, because there's always exceptions to rules, but a lot of times that's what it means. And so if you get a number over 0, you can safely say the limit does not exist, because we have a number over 0. I mean, that's undefined, and undefined means that the limit's not going to be happening, okay? Now, if it was a hole, okay, be careful on a hole, because a limit can exist at a hole, but it cannot exist at a vertical asymptote. So how are you going to know that it's not a hole? Well, try to factor and cancel, okay? Remember, if it factors and cancels, that's okay, but if it doesn't, it's definitely a vertical asymptote. It definitely does not exist, okay? So let's show another one that you might get something like undefined. The limit as x approaches 0 for 3 tangent of do this. Let me change this. Sorry guys, if you're writing in pen, I'm sorry, let me change this. Okay, so let's pretend that you're asked to find the limit of 3 tangent x's as x approaches pi over 2. Well, with trig, you know, you try direct substitution, and what's going to happen is you're going to try to plug in pi over 2, and you're going to get 3 times. Okay, let's try to remember this. The tangent is the y over the x. So at pi over 2, what is the y over the x? Well, that would be 0 over 1. And I'm a liar. It's the other way around. Haha. The y is 1, the x is 0. So when you do that, what is this number? Well, this number is undefined. And so 3 times undefined is undefined. So this is another does not exist. And if you knew the graph, some people are better with graphs. If you remember the graph of tangent, it has vertical asymptotes whenever it's at pi over 2 or pi or 3 pi, or sorry, just pi over 2, all the over 2s. Pi over 2, 3 pi over 2, 5 pi over 2, okay? And that's how you could know that one. Okay, so then there becomes the case of, well, when is it does not exist? Because there are so many of my class that would take a limits test, and if they tried to plug it in, like if it didn't work, they'd always just go, doesn't exist, doesn't exist. And I was like, slow your roll, because there is something called an undeterminable fraction. Now, an undeterminable fraction is when you have 0 over 0, or you may have like the infinities over themselves. If you have a situation like this, guys, you don't know what the answer is going to be. This is called undeterminable, and you please do not answer with does not exist. Okay, sometimes it still may not exist, but usually the limit does exist. You just have to figure it out. An example of something like that, we're going to do several examples of this. In fact, I may be short a box, but one example of something like this may be, I'm going to keep that x minus 3. Okay, something like that, okay? So you may see this, and you may try to plug in the 3, and you're going to get 0 over 0, okay? Now, that doesn't mean does not exist. It does not mean the answer is 0, okay? What you have to do is sometimes look at it and see if it factors. And I'm going to write that in a different color because this is one of your techniques. If you get undeterminable, try to factor first. So if you try to factor, y'all are probably already a step ahead of me. That's going to factor, that's going to factor, and then what's going to happen? Cancel, cancel. Now can you plug in the limit as x approaches 3? Well, yes, I can, and the answer is 6, okay? So just because you get one of these 3, you got to do more work is what that means. So case 1 would be, factoring here. Case 2, let me try to make one up here. As x approaches, let's say -1. And we will do 1 over x minus 1. Oops, hold on a sec. Okay, this is probably a good one. Okay, so whenever you see fraction madness happening, and you can already identify right off the bat that you plug in a -1 and that's a 0. And then if you look up here and you plug in a -1 here, hold on, I'm going to have to do something. I'm going to have to change this, hold on. Haha, let's do that. I want it to be 0 over 0, so I'm having to change it a little bit. I'm so sorry. Okay, this will give me 0 over 0. Now, when this happens, we don't know what to answer. It's going to be undeterminable. So, on this one, there's no trick like factoring. I mean, it's just put it together, like simplify. So, trick 2 is just simplify what's already given. And what I mean by that is, like, look at these two fractions. You could totally put those together. So the common denominator would be 2 times x minus 1, because you just take each denominator and multiply them by each other. This one was missing the 2, so I need to multiply the top by 2. This one was missing the x minus 1, so I need to multiply the numerator by x minus 1. And then on the bottom, we have an x plus 1. Okay? So when this happens, then we simplify this. We've got 2 plus x minus 1. Well, that's an x plus 1 over a 2 blah, blah, blah over a blah, blah, blah. Okay, there we go. So what do you do with a 3-part fraction, guys? There's 2 things you can do. You can either stick this over 1 and then do the whole multiply fractions, don't ask why, flip the second and multiply. You can do that, okay? Or when I have a 3-part fraction, just to shortcut it, I'm pretty good now at realizing that the bottom 2 denominators, like these will go together. So they're going to end up side by side. So this is going to be the same thing as x plus 1 over 2 x minus 1 times x plus 1. That's what's going to happen. So when you do all that, then notice this. Now this x plus 1 is going to cancel with that x plus 1 and just leave a 1 on the top. And now you can try to plug that number back in. So on the top you still have a 1. On the bottom, we now have a 2 times, well, what's a negative 1 minus 1? Well, that's a negative 2, so negative 4. So that would be the answer there. So simplify, and if you want to write a note there, this is anytime you have crazy fraction, you know, just think common denominator. And maybe that can be your trick. Think common denominator, and that'll help trigger you to put all that junk together. So we've got 2 tricks so far. If it's 0 over 0, try to factor and cancel, or just try to put fractions together, get common denominators, and see what you can make happen. The last one, I'll switch to a different color because I didn't do an extra box for it. This is whenever you have a radical, okay? So limit as x approaches, I gotta think about this one too, yay. Alright, let me make one up that works. Hold on just a sec. Cool, figured it out. Alright, so here's your last example of a problem where when you look at it, it looks all weird. You try to plug in the 2. Direct substitution is always what you try first. This will leave you with a 0 on the bottom, 2 minus 1, 1 and a 0 on top. So it's undeterminable. So that means try something first. Now, here there's no way to factor this. There's no denominators to get together, no fraction inside of a fraction. So you're dealing with a weird radical, and you may remember from back in like Algebra 2, if you've got weird radicals everywhere, one of the tricks you can always try is called the conjugate. You can multiply this by the conjugate of what you see. Now the conjugate is a crafty way to get rid of radicals, and what you do is you just recopy the radical and then you change the sign of whatever it was with. Okay. Now to make it fair, you have to do the same thing to both the top and the bottom. But this right here, let's write the word down. This is our conjugate trick. And this is a nice trick anytime you see radicals, okay? Remember, you still have to get the 0 over 0. Always try that first, but then this will work. Okay, so now we just multiply across the top and across the bottom. Now, across the denominator, guys, I'm actually just going to recopy that because that's going to be a nightmare to multiply out. And the goal is hoping that something will cancel this out so that I can do this problem. So I don't want to multiply this all out and then not be able to factor it back out. So I'm just going to leave it all ugly like that. But the top, I'm definitely going to FOIL. When you FOIL the top, you're going to get x minus 1, and then a positive one of those and a negative one of those. So those will cancel each other out, and then another minus 1 in the back. So your FOIL ends up looking like this, and x minus 1 is really x minus 2. Ah, I see it. Do you see it? Okay. This is really awesome because now numerator to denominator, those cancel. And now you can come back and say, well, what was I trying to take the limit of? Well, that was a 2. So now let's plug that 2 in and see what we get. So I'm getting 1 over 2 as my final answer. Woo! Fun, isn't it? Okay, so those are all the little tricks. Try direct substitution first. If not, see if it's a number over 0, in which case the limit does not exist. But then if it's 0 over 0, you now have several tricks to try. Factoring, common denominators, or the conjugate. dealy bopper. So good luck on the homework.